So we are at Numerai, actually the hardest data science tournament in the world. So this is a platform, it's an American platform that is used to predict the stock market. So this platform, we have the data sets from the stock market that is being released weekly, and the predictions are made by the data scientists. The data scientists that are crowdsourced from every part of the world. They build their models and they will make predictions on the data sets. And from the several of the models that are being submitted, the platform Numerai will make a meta model from all those models and use them to make the predictions of the stock market. So far they have paid over 31 million USD to data scientists, and the models that have been taken are over 5,000 models. So here in this data platform, normally data science, we say 70% of the time is spent in cleaning up the data, and then the remaining percentage, 30% is used for the building of the model and making predictions. But here, the data is already clean, modularized, so there's no need for data cleaning. Data cleaning in these data sets. And also, it is obfuscated. Or in other words, it's anonymized. Because this is a financial data and it is very private, so there's a need for the hiding of the details of the data. So it is anonymized data set so that it can be given out free of charge. So once you get this data, you see that it's always mostly in numbers. Numbers that are in codes, so that we can easily work on the data set. In the data, we have the features and the targets in the columns. So now we have over 1,000 features. It's a real big data set, 1,050 features. Usually when we started in 2017, the features were like, they're not even up to 50. But with increase in accessibility to compute power and decrease the price of computing costs, you can afford to have a lot of features in the data set, and a lot of even volume of the data set has even increased. So each ID, the ID we're talking about is here. Each ID corresponds to a stop at a specific time error. And then the features describe the various quantitative attributes of the stock at that time. We make the target. The target is the part for the predictions to know which is which. I think it's not binary. I think it's multi-classification because it's not only 2. So we have 0, 0.25, 0.5, 0.75, and then 1. Either multi-class or multi-level. Usually multi-level, multi-class classification. So here we apply machine learning to predict the stock market. In this case here, you see what was used in the example here was the XGB regressor, XGBoost. And then build a model and fit the data to the model and then make the predictions. We are submitting actually the CSV file. So they will now extract the model from the CSV file and assume it to other models to make a meta model. So, and then we submit it. So, after building your model, you stake the model actually. So they can move it in the cryptocurrency. The cryptocurrency of Numerai here, it's Numerai. I think it's somewhere here. So one Numerai is 16.71 USD currently as of today. So over 31 million USD in Numerai has been paid to data scientists. So this is it about Numerai. And so this is the leaderboard for people who have built their model, made their predictions, and also staked their model. Like this. Staked over 23,000 Numerai for this shattered NX. These are several of the data scientists who have assisted the leaderboard according to the degree of their rank in the predictions. So I tried out this, downloaded the data sets and used my model and made a submission. So this is my the GitHub repo where I ran the prediction. So it was this, so I call it stock market predictions. So it's one of the difficult predictions and principal tasks for experts because of market volatility and several factors that influence the value of the stock. But with the introduction of deep learning and the accessibility of huge compute power, and also the anonymization and democratization of financial data, platforms like Numerai can make data stock market predictions easier. So how is it predicted? The summary of whatever I did was I used medium. So we have the small, the medium, and the large portion of that depending on the compute power. I opted out for the medium because I don't want it to be very small to be useless to compute, but I also don't want it to be very big because I don't have access to much computer. So I made use of medium. In this case, I'm using 30 gig RAM. So I used that from the Cargo platform. The Cargo platform has that feature where you can have access to. So I think it's loading. Have access to their RAM in the cloud. And so the access, I had access to the 30 gig of the of RAM for Cargo. So the medium contains 472 features. And I also got the per error correlation of each feature with the largest, and use the information to get the 50 riskiest errors. So among all the errors, I think there are many errors, more than 1,000 errors. Okay, that is for the features. But for the errors, I chose the first 50 in the rank of risk. So the 50 riskiest error that I choose by checking the largest correlation differences within each error. So the prediction, that is the validation and the prediction of the model, that is the validation and live predictions. We are neutralized to the 50 riskiest features. And are ranked from 0 to 1 to meet the Numerai upgrade requirements. So my Sharpe ratio, neutralized predictions was 0.973, around that. And then for normal predictions was 0.5. So the Sharpe ratio I got was 0.973, and it can also be improved. So this is a very good platform, the Numerai platform. The little datasets can come in and make their predictions and derive value from their financial data. So this is the code which I used. I used light GBM regressor and then imported my models. And then of course I have accounts with Numerai, so I used my keys and then my password to be able to have access to it. And then I read the current round. And the data site is in packets. I downloaded it, read the data set, and then so I have the training data, the validation data, the live data. Then organized my data according to the error and choose the 50 riskiest features. So after that, I built my model. I simply ran my predictions. And you can check through my Cargo notebook or the GitHub repo to see the details of the code. So here I have the predictions of the models that were targeted for the 50 riskiest features, which in this case the Sharpe ratio was 0.973, like I said before, and then the normal prediction for the target data set was 0.85. So this platform is a very good platform, especially for people who have just finished learning the basics of data science the application, the use of machine learning and deep learning. They just want to experiment and try out what they have learned on a real project, because even the data set that are given here are real data sets, stock market data sets, financial data sets, but they are anonymized and obfuscated. So it's good for you to try out your skills using this platform, and then see how you can make improvements as the day goes by. So this is just a brief cap of the platform, the Numerai platform for freelance data scientists. You should try out this platform, work on your data sets, and make predictions. You can give the feedback in the comment section in this video, and I hope to see that in the next time. Okay. And bye for now, and then till the next time, I'm going to share other things I've learned, other applications of data science and deep learning.